Welcome to this short review of the innate immune system. Hi, I'm Christopher, and in this video, we'll review how the innate immune system protects us every day. This is the part of the immune system that is fast, broad, and always ready. It does not need prior exposure to begin working, and without it, we would not survive very long in a world full of microbes. Before we get into details, let's take a step back. What is immunology really about? Immunology is not just a list of cells and molecules. It is the study of how the body protects itself. We study threats like bacteria, viruses, protozoa, fungi, parasites, prions, and other agents that can harm the body. But we also study the defenders. In a sense, immunology is the study of the good guys and superheroes. It is a study of how the body recognizes danger, responds to threats, protects tissues, and sometimes, when the response is too strong or misdirected, causes damage along the way. There are two major branches of the immune system: innate immunity and adaptive immunity. The innate system is typically where we start because it's the body's rapid first defense against pathogens and tissue damage. It also helps set the stage for adaptive immunity. Adaptive immunity includes the humoral branch, which uses B cells and antibodies, and the cell-mediated branch, which uses T cells to target infected and abnormal cells. We'll cover adaptive immunity in another video. For now, our focus is the innate immune system. This system has some impressive defenders. Innate immunity is both fast and broad, but it does not have classic antigen-specific memory. That means it does not remember one specific pathogen the way the adaptive immunity does. If the innate system encounters a bacterium, a virus, or a parasite today, but then encounters that same pathogen again later, it does not usually mount a faster, more specific memory response. Instead, it responds using broad recognition systems that detect common patterns of danger. But that does not mean that the innate immunity is simple or weak. It stops countless microbes every day. Without innate immunity, we would be overwhelmed. And without innate immunity, adaptive immunity would have a much harder time getting started. The innate immune system can feel confusing because it involves many different kinds of defenses. Some are physical structures like skin, mucosal surfaces, fur, cilia, and even nasal hairs. Some are cells that veterinarians see on blood work or cytology, like neutrophils and monocytes. And others are molecules, such as the complement proteins, cytokines, chemokines, and acute phase proteins. So instead of thinking of innate immunity as one thing, it helps to group it into categories: barriers, cells, soluble mediators, and recognition systems. Let's walk through those major categories together. Barriers are the first line of defense. Skin, mucosal epithelium, mucus, cilia, saliva, tears, urine flow, normal microbiota, antimicrobial molecules, and low pH environments all help reduce the chance that microbes reach deeper into tissues. These barriers are not just passive walls. They trap, flush, inhibit, and compete with microbes. Normal bacteria in the skin and in the intestines can also help protect the body by competing with potential pathogens. You can think of barriers like the outer defenses of a castle. They do not stop every invader, but they greatly reduce how often the deeper defenses are needed. Sentinel cells and phagocytic cells are early cellular responders. Sentinel cells act like lookouts. They detect danger in tissues and help start the immune response. Macrophages, dendritic cells, neutrophils, and monocytes are all important players here. Many of these cells perform phagocytosis, and that means that they engulf and digest microbes and debris. The word comes from Greek origin, meaning to eat and sell. So phagocytosis literally translates as devouring a cell. Dendritic cells are especially important because they can capture antigen, process it, and help present it to the adaptive immune cells in lymphoid tissues. This is one of the major ways innate immunity helps launch adaptive immunity. Other innate cells help amplify inflammation and attack abnormal cells. Mast cells release inflammatory mediators that can change local blood vessels and recruit other immune cells. Eosinophils are especially important in responses to parasites and allergic inflammation. Basophils circulate in the blood and contribute to inflammatory responses. Natural killer cells are another important innate cell type. They can recognize and kill infected or abnormal host cells, especially when cells show signs that something is wrong. Together, these cells help raise the alarm, intensify the response, and contain threats early. The innate immune system also includes soluble mediators. Complement proteins can help kill microbes, mark pathogens for phagocytosis, and promote inflammation. Cytokines and chemokines allow immune cells to communicate, recruit additional cells, and coordinate the response. Acute phase proteins are produced mainly by the liver and help support systemic defense during inflammation. Interferons are especially important during viral infections because they help warn nearby cells and limit viral spread. These soluble mediators do not replace immune cells. They help signal, recruit, amplify, and coordinate the innate immune response. Innate immunity also depends on recognition systems. Innate immune cells use pattern recognition receptors, or PRRs, to detect common signs of danger. These receptors recognize broad patterns rather than one highly specific antigen. PAMPs are pathogen-associated molecular patterns. These are common microbial features such as bacterial cell wall components or viral nucleic acids. DAMPs are damage-associated molecular patterns. These are signals released by injured or stressed host cells. So innate immunity can detect both something microbial's here and something's been damaged. And that helps the body decide when to raise inflammation, recruit cells, and begin containing the threat. Remember, innate immunity involves everything from barriers like skin, mucus, and even nose hairs, to living cells like neutrophils and macrophages, to soluble mediators like complement and cytokines. It works constantly, second by second, to protect the body. It recognizes broad patterns of danger, contains many threats early, and helps provide critical information to the adaptive immune system. The innate immune system is fast, broad, and ready now. It buys time, limits early spread, and sets the stage for adaptive immunity. Thanks for watching. I'm Christopher Lee, and what you understand today helps you protect patients tomorrow. And I'll see you in the next video.